Today we're going to take a look at factoring trinomials. The last couple days we've factored things with 4 terms and by factor by grouping, and we've also factored with any number of terms by factoring out the greatest common factor. So you're going to learn to factor trinomials. In order to factor trinomials, we're going to multiply A and C, and we're going to find factors of that, or things that multiply that to add to B, and then we're going to do factor by grouping. So in this case, my A is 1 and my C is 10, so I need factors of that add to B. So factors of 10, and sometimes it helps to write them all out, are 1 and 10 and 2 and 5. 1 and 10 adds to 11, but 2 and 5 adds to 7. So we're going to split this middle term, and we're going to get g squared plus 2g plus 5g plus 10. And then we're going to group. So we've got g times g plus 2. We're going to factor out a 5 here. And when we do that division and factoring that out, I get g plus 2 again. So just like what we've been doing the past few days, this factors to g plus 2, and then the g plus 5. Okay, so that trinomial factors to these two binomials. Again, I need factors of 1 times 25, or 25 that add to negative 10. Now in this case, my factors of 25 are 1 and 25, and 5 and 5, and neither of them add to 10. However, negative 5 and negative 5 multiply to 25, but they add to negative 10, so that's what we're going to use. So we're going to split the middle term, so negative 5k minus 5k plus 25. Notice that those add to that middle term, so we haven't really changed the value of that expression, which is why this works. I'm going to factor out a k out of the first pair and get k minus 5. Because this term is negative, I'm going to factor out a negative 5 in the second pair, and I'm going to get that k minus 5 again. So I get k minus 5 times k minus 5. We can also write that, because there's 2 of them if we wanted to, as k minus 5 squared. Sorry. In this case, we're going to, again, 1 times 18 is 18, and factors of 18 that add to negative 11 are going to be 2 and 9, and again, they're both going to be negative. So x squared minus 2x minus 9x plus 18. I'm going to factor out an x, and I'm going to get x minus 2. Second pair, we're factoring out a negative 9. That also gives us x minus 2. So I get x minus 9 times the quantity x minus 2. So it's really all about looking for patterns and making the patterns work for what we have. Okay, now notice this time this is negative, so we're looking for factors of negative 40 that add to negative 3. So that means one of my factors has to be negative and one has to be positive. So, and because it's negative 3, we want our larger of our factors to be the negative. So 1 in 40 would be 1 in negative 41, that only adds to negative 39. 2 and negative 20, which adds to negative 17. 3 does not go in evenly. 4 and negative 10, which adds to negative 6. I almost said 7. 5 and negative 8, which does add to negative 3. So these are the factors I'm going to use. Whenever possible, I like to put the negative here so that my factors, when I'm splitting, go positive, negative, positive, negative. Then I don't have to worry about factoring out a negative. So if I factor out a p, okay, I'm going to get p minus 8. And here, if I factor out a 5, I'm going to get p minus 8 as well. So this factors to p plus 5 and p minus 8. Okay. Now notice that this one's a little bit different. I have a number in front of my first term, so a is 3. So I'm going to multiply 3 times negative 6, which is negative 18. But I still want factors that add to that 7. So I've got 1 and 18, and again, one of them has to be positive and one has to be negative in order to multiply to a negative number. But this time my middle term, it is negative, so my larger will be negative. So 1 and negative 18 adds to negative 17. 2 and negative 9 adds to negative 7. So I've got 3n squared minus 9n if I split this middle term and bring down the outsides. And that's that same expression, just rewritten a little bit different. I'm going to factor out a 3n, and that's going to give me n minus 3. Now out of here, I'm going to factor out, that should be plus 2. I'm going to factor out a 2, so I get n minus 3. So my factors are 3n plus 2 and n minus 3. A lot of examples today just because there's a lot of different things that can happen with factoring. My geometry kids are sitting here nodding and wishing that I was giving this lesson during their last test when they had to factor. All right, so now also, you want to check for a greatest common factor. I can't pull anything out of here. They're not all divisible by a number. So again, I'm going to go right to multiplying 3 times 8, which is 24, negative, that add to negative 14. So 1 and negative 24 adds to negative 23. 2 and negative 12 add to negative 10. Okay. 3 and negative 8 adds to negative 5. And then we're back 4 and negative 6 adds to negative 2. Now we're back to the beginning. So those are all of your factors, and none of this works. So we can't factor this polynomial. We say that it is prime. Here, all of my numbers are divisible by 2. So I'm going to factor out a 2 first. I'm going to get 2 times 2y squared plus 7y plus 3. And now I need factors of 6 that add to 7. And that's just going to be 1 and 6. I always forget that when I'm factoring. I look and look and look, and then I'm like, oh, that's so silly of me. So by factors, I'm going to split the middle term, are 1y and 6y. And I'm going to factor out a y from the first pair. I get y times 2y plus 1. Out of the second, I factor out a 3. And I get 2y plus 1. So I get y plus 3 from here and here. And 2y plus 1. Now I factored out a 2 originally, and that's going to go out in front. Because all of your factors should multiply to what we started with. Right. Another example, I think this is the last one. All of these are divisible by 3, so I'm going to factor out a 3. That's going to give me 6x squared plus 11x minus 5. Minus 10, sorry. So I need factors of negative 60 that add to positive 11. This time it's positive, so my larger number will be positive. So -1 and 60 is -59. -2 and 30 is -28. -3, oops, positives. 3 and 10, 20 is 17. 4, -4 and 15 is positive 11. 5, -5 and 15. Nope, -5 and 12 is 7. -6 and 10 is 4. 7 and 8 don't go in evenly, neither does 9. So once again, this can't be factored any further, okay? Can't be factored any further, but we don't say this one is prime because we've already factored out a 3. Okay, so today we have looked at all kinds of factoring with that trinomials, and where we multiplied the first and the last term, the coefficients. We wanted them to add to the middle term. We split that middle term and then did factor by grouping. So you guys have a math-tastic day.